Reactions in aqueous solution. So we're going to revisit, as I said, double displacement reactions. So two outcomes can occur as a result of mixing two aqueous ionic compounds together. Okay, so similar to a double displacement reaction. The compounds will remain in solution without reacting. So what happens is if both of the solutions are soluble in water, right, they will dissociate and you really wouldn't see anything. Right? So we saw one of the double displacement reactions in one of our labs way back when, that we really saw no reaction occurring. Right? So both ionic compounds actually ionized, okay, dissociated within the water. And the other thing, one aqueous ionic compound will chemically react with the other. So we'll be seeing the idea of either a precipitate forming, as in several double displacement reactions. We're also going to see how gases can be formed in these double displacement reactions. So there are a few types of reactions that you're going to have to remember, and there are a few tips to identifying these types of reactions, and you're going to have to memorize some of them. So let's recall the double displacement reaction, where the metals of two different compounds exchange places. Metals only replace metals, and the non-metals. Okay, so you can treat it as one or the other. The metal will replace the other metal, or you can just switch the two non-metals with one another. Okay, so imagine here, all right, we've got our metal, always followed with our non-metal, metal followed by a non-metal. So we're going to rewrite them the same way and watch the switch that's occurring, right? So we can either switch the metals or we could switch the non-metals, doesn't really matter. The order in which we write these, okay, if I want I can write this one first, doesn't really matter. But always make sure that you're always writing your metal first. So possible evidence of a double displacement reaction include formation of a precipitate, so that ions are removed from solution as an insoluble solid. Okay, so the idea of a precipitate, we're looking at a solid that will not dissolve in an aqueous solution, will not dissolve in the water. Formation of a gas, so that the ions are removed from solution in a form of a gaseous product. Oftentimes, with these reactions, these are double displacement reactions that appear as double displacement reactions, but include an extra decomposition reaction. Right, so one of the compounds, one of the products, actually further decomposes into a gas. And the last one here, formation of water, so that the hydrogen ions and the hydroxide ions are removed from solution as water. Common one, right? Neutralization reactions, formation of water. So double displacement reactions that form precipitates. These types of reactions are also known as precipitate reactions. Don't worry about naming it as a different type of reaction. It's double displacement. But another way we can explain these double displacement reactions is to call it a precipitate reaction. But don't worry, just keep it as double displacement reaction. Identify the state of the products of the following reaction. So we have the following. Lead 2 nitrate plus potassium iodide. And I've already kind of completed the switch, right? So the lead and the nitrate, the potassium and the iodide. So notice how the metal, okay, switch places with one another. Now, we know that they're both in aqueous solution. So we have to identify which one will remain as aqueous, which one will remain as solid. To do that, you need the solubility table. So let's look at the following. So we're looking at K in the in our guideline, and here's K. Right? What do we say? K is soluble. So it's soluble. Nitrate. What do we say about nitrate? Also soluble. So if the two are soluble, obviously this whole compound is soluble. But not only that, right? What happened would have been if one of them was insoluble. Well, the next step would be to look at the guideline. The higher the guideline, that's the one that's going to overpower any of the lower guidelines. But since they're both in guideline number 1, right, didn't really matter. Right? So if we had something else in here with nitrate, the nitrate still would have overpowered whatever the other guideline would have been if it included any one of these lower ones. So we know it's soluble, so because they're soluble, they will actually dissociate in water. Right? So they will separate into your potassiums and your nitrate ions and allow the water to surround it. So, because they're soluble, the state in which they're in is aqueous. Let's look at the next one. Pb and iodine. So, let's look for Pb. Here's Pb. So Pb says we're insoluble. Iodide is right here, and it says it's soluble. So now we have one that's soluble, one that's insoluble. The next thing to look for is the guideline. So lead belongs to guideline number 2. And iodide belongs here to guideline number 3. So the higher up that we are in the guideline, that's what's going to overpower the entire, or pretty much offset the lower one. So because the higher guideline is 2, 2 says we're insoluble, this one is what's going to precipitate. So in this reaction, right, the precipitate that we're going to form in our solution, so we're going to have our solution, or our final product, and we're going to have the precipitate forming. That precipitate that's forming here is the PbI2, the lead to iodide. So you got to use the solubility guidelines to solve these types of double displacement reactions.